Good evening, everyone. Welcome to our last section of Unlocking PSP. I want to take a minute to give a thank you to some people that allow us to do this and tell you guys or girls how this project started. Um, First, I want to give thank you for all of you that have been with us for 10 weeks. And it has been a pleasure for me, for Alan, to be here and share some acknowledgement and try to help you and you help us. At the end, I think that both of us are helping each other. I start this project as an internal project for my company, the company that I work with, that is PrepTech. I started the project to help my coworker to get the certification. But after I was thinking about this, and I decided to post this in the Axis Connect, and I got a lot of requests to open the um, the study group for other people outside of the company. Uh, that that was the reason I opened the study group, and I posted in Axis Connect that I was looking for some help, some mentors to help me to handle this study group. And Alan uh, connect with me, and he said, "Oh, I can help." And it has been great for me having Alan has been a huge help adding or providing us his knowledge in managing the presentation. And I want to give Alan a huge thank you for being here for these 10 weeks. On the other hand, I want to give thank you to PrepTech, because the company that I work with allow us to use the resources, the team meeting that we use. We are doing this after hour for, at least for me, but all the resources that I am using, the software to create the presentation is provided by the company, and the Teams meeting is provided by the company. For me, it has been great to use the resources. This company believe in professionalism, believe in education, and believe in career path. The company provide a huge bonus to the people or to the employees to get the certification, and also a huge salary increase, annual salary increase. Big thank you for PrepTech for allowing us to do this. Say that, now welcome, Alan. You can take the control as
Okay,
every
great.
week.
Yep. Thank you very much, Nelson. Thank you. And it's been a lot of I really enjoy doing this. So it's fun for me to do this. I learn every time I do the presentation, actually, from others and from just researching. So I have certainly no problem doing this. Okay, so let me share my desktop. You should see that slide, which is going to pop up in a second. Let me move this out the way here. I can pop up first slide. So we are going to be covering domain 3, essentially tasks 3 and 5 tonight. But before we start, Nelson wanted just to clarify, and I did too, of course, some points on domain 3, tasks 1, 2, and 4, which we have already covered. So this is based on information from the body of knowledge, the PSP body of knowledge, which, if you don't have it, is on the ASIS website for free. If you can see this PDF up here, It basically gives you the various breakdowns of the domains and what you should know, what your knowledge should be. So they call it the body of knowledge. And for instance, task one, domain one, you should have knowledge of these areas and so on. By the way, domain one is 34% weighting. It's 34% of the test will be on that part. 35% on domain two, and what we're covering today, domain three, 31%. So before we do anything else, let's just go to the body of knowledge points on domain three, task one. We just wanted to clarify what these are. So these are the points that you should know about. You should learn this or be knowledgeable of this, because there's could well be questions on any of these subjects. So the first one is the bid process that we discussed last week. Things like site visits, RFI, substitution requests, pre-bid meetings, all that sort of stuff. RFI, of course, is what typically gathers market data and vendor capabilities. An RFI basically educates. And then the bid package types, RFP, RFQ, IFB, and sole source. So you should be knowledgeable on these. And these are all nicely described in the ASIS protection of assets, the POA. Just as a refresher, RFP is compares. It's a request for proposal. It compares responses from various vendors. RFQ is typically pricing. It requests for pricing for a project items. IFB is invitation to bid. It focuses on pricing for well-defined requirements. And sole source, of course, is when you can only source from one supplier, mainly because of they perhaps might have unique expertise. Maybe it's compatibility with any existing equipment. Maybe the vendor holds exclusive rights to something you have, so you have no choice but to go with one vendor. Bid package components, project timelines, cost, personnel, documentation, scope of work, criteria for evaluation of bids, cost, experience, scheduling, certification and resources, technical compliance criteria, and ethics in contracting. So these are all domain three, task one. This is what you should focus on, and this is what you should try to be knowledgeable of. For domain three, task two, we're looking at vendor evaluation and selection. For example, interviews, due diligence, and reference checks, and project management functions and process, and the procurement process. So those are all highlights of the body of knowledge of domain three, task two. Moving on to domain three, task four. This is subheaded develop requirements for personnel involved in support of the security program. So this is defining roles, responsibilities, and limitations of security personnel. And we covered this last week in quite some detail. Human resource management, establishing key performance indicators, performance reviews, recruiting, onboarding, that sort of thing. Security personnel professional development, training, certification, general post and special orders, security personnel uniforms and equipment, and security awareness training and education for non-security personnel. I did cover this kind of fast because you can read this if you have if you obtain the body of knowledge document from ASIS, the PSP body of knowledge, sometimes called BOK. So yeah, look at that. Those are the highlights. Those are what you should read up on these various domains. So if no questions, we'll move straight on to domain three, task three. Manage implementation of goods and services. We're going to be covering domain three, task three, and domain three, task five today. So let's get started right away with domain three, task three. So I like the way Nelson has this laid out. We start with like a high altitude view, and then we kind of come down to get more detail. So this is what we're going to be covering tonight. Site preparation, coordination, installation, testing, warranty, and training, designer, contractor, owner, rep, shared accountability, and the importance of planning early. So we'll go through all this in great detail, but basically Make sure for site prep, make sure the physical environment is ready for installation. Coordination and installation. This is where the designer, the contractor, and the owner's rep must work closely to ensure everything aligns with the specifications and the overall security plan. We then move on to, after installation and everything else, we move on to testing, warranty and training. So testing validates the equipment, warranty protects your investment, and training equips users to operate confidently. Designer, contractor, owner, rep, share accountability. Very important. People have to know what their accountability is. It should be shared across all parties, and each has a role in ensuring success. And of course, always early planning is critical. Address risk, costs, schedules upfront. And the final takeaway on this 100,000-foot overview is effective implementation depends on planning, collaboration, and accountability, not just the installation. So on that note, let's then start with site preparation, the first block that we saw on the first slide there. So site preparation begins with verifying the design package and equipment locations. Everything needs to match exactly the approved plans before work starts. And if the contractor at this point reports any changes, they should be in writing. They must be in writing. There's nothing worse than undocumented changes on a project. It can screw everything up big time. No changes are allowed without formal approval. Inspect and document existing equipment. This creates a baseline and avoids disputes later about what was already there. And make sure the contractor knows that they are liable for his, or he's accountable, and any negligence on the installation is totally in his ballpark. So final takeaway on this slide, thorough preparation and strict accountability prevent errors and disputes during installation. Let's now move on to contractor coordination. So contractors need to carefully manage time, manpower, materials. It's up to them to keep on schedule. And poor planning leads to delays and cost overruns. So a clear schedule aligns security work with the broader project timeline. Remember that security interfaces with many different systems. You've got electrical, IT, the fire alarms, and building automation. So this makes coordination especially critical. Every connection point needs alignment to avoid conflicts. If there's any missing precursor work, and what I mean by that is conduits, power feeds, network cabling, if some of that has not been done, contractors should flag these gaps early, because that can mess up the entire project if it's not documented too. It also protects the contractor, right? If they want an extension or whatever, then as long as they have it documented that something's missing that enable them to, or it means they can't do the work, then that's got to be documented. Avoid poor environments. What that means is basically don't install it in unfinished or unsuitable areas, dusty atmosphere, wet, or maybe even improperly powered. That can make a real mess of the installation before it even gets up and running. And cross-trade coordination is very critical also. That includes the electricians, the IT teams, and general contractors. So the takeaway on this slide is successful system implementation depends on strong contractor coordination, proactive scheduling, communication across trades, and attention to site readiness prevent costly rework and keep the project on track. Rework is the worst thing. To have to go back and redo something is a real problem for any project, as you know. So let's now have a look at an overview of the installation. So installation and operation, it's more than just mounting devices to walls or poles or anywhere else. It's about ensuring the system works as intended in the operational environment. So each step must align with the design intent. Component installation, every device, it could be cameras, access control panels, readers, access control readers, or sensors, they must be placed exactly as specified in the design package. Small deviations of any kind can affect coverage, detection, capability, or system reliability. Features and considerations. Installation should account for environmental factors, obviously like the weather, lighting, interference, and ensure compliance with codes, standards, and the end user's operational needs. And we'll talk about this later too. Tuning, fine-tuning the system once installed. Every type of sensor has some sort of calibration procedure. If it's a camera, it could just be focusing the lens. It could be angling the camera correctly. With a sensor, with a beam sensor, for instance, it could be lining up the transmitter and receiver parts so they can form that beam. So everything needs to be tuned and calibrated. Final takeaway, proper installation is not just technical. It ensures the system operates as designed, providing reliable security and value to the organization. Some more notes on installation and operation. When it comes to this, the first priority should be ensuring that all work follows applicable standards and codes and manufacturer guidelines too. This guarantees compliance and safety, and it protects yourself too, or speaking perhaps as an integrator or a contractor, it protects yourself if you make sure that everything is done per code. Installers must then handle connections and adjustments, whether it's electrical wiring, network cabling, or system calibration. Any small error here can cause system instability or future maintenance issues. We'll talk about maintenance later. Any pre-installed or already installed customer provided equipment, they sometimes involve equipment that's already there. So contractors must integrate owner supplied hardware properly and ensure it operates correctly after the fact too. Just a word, I tend to use the term integrator a lot as well. A system integrator should be capable of installing multiple types of systems, whether it's sensors, access control, or surveillance video. They should be capable of doing that. We'll discuss that a little more, but I may also use the word contractor or installer, but basically they're all pretty much meaning whoever is installing the system. And finally, again, we'll talk about tuning after the install. It's important to do this. Fine-tune performance, sensors, cameras, and alarms are calibrated. That's very important. And the final takeaway, a proper installation isn't finished until it has been adjusted, integrated, and tuned for reliable operation. So here's a word on component installation. And what I mean by component, of course, bless you, I mean cameras, readers, strikes, the individual components of the PPS. So for readers, strikes, and mag locks, we should emphasize the importance of correct placement and secure mounting. Any improper installation can cause failures and increase maintenance too. Detection placement, those are the detectors of sensors. They must be positioned to minimize false alarms. False alarms, of course, we learned a few weeks back, false alarms are typically caused by sensor misalignment or sensor problems, sensor installed incorrectly. And nuisance alarms are typically caused by animals, birds, trees waving in the wind, that sort of thing. So they should be placed to reduce false alarms. Video, make sure you're using PoE category cabling less than 100 meters. And that if you have any cameras, outdoor cameras pointing east or west, make sure you're avoiding any glare. Sometimes it's very difficult not to, but if you avoid glare, or if you have glare in your video camera through your video camera lens, it can really mess up the video quality. It can more or less blind the camera. Any panels, access control panels, these are, of course, the brains of the system. They should be secured, properly powered and accessible only to authorized staff. They should be locked, or they should have security enabled screws and tamper resistant screws on them. And of course, always follow NFPA 731. That's a standard that governs installation practices for physical security systems. And the final takeaway on that slide is proper installation is not just about making it work, it's about ensuring long-term reliability, compliance, and performance. And following standards like NFPA 731 protects both the system's effectiveness and the installer's liability. Some features and considerations. Infrastructure. So that's basically the foundation. The solid foundation basically matters. So conduits must be properly routed. Grounding must meet safety standards, and all wall or floor penetration should be sealed to maintain integrity and compliance. Any poor infrastructure mishaps or installation can cause long-term reliability issues, of course. So startup checks, verify wiring, power, and protected devices like surge suppression. This ensures that the system is stable and safe before operation begins. Load any configs and maps into your system. All devices should be loaded with correct configurations. Clear documentation ensures troubleshooting and future maintenance can be performed efficiently. Make sure that any critical circuit runs on a supervised line or is a supervised line. We spoke about this too. It's basically a method of, could be as simple as a resistor across the line that's a known resistance value. If that goes north or south of that, then it's a alarm as a broken cable or a tampered cable. And enclosures, any enclosures for housings, for sensors or cameras, they should be weatherproof. They should be IP66, at least 67 for ingress protection, and they should have tamper resistant screws on them too. And cabling for NEC, for electrical, UL standards, and ADA accessibility. All that compliance needs to be correctly introduced, and it protects the system from liability. Final takeaway on this slide, successful implementation isn't just about installing devices, it's about ensuring the infrastructure, documentation, supervision, and compliance all work together to deliver a safe and reliable system. So all of this must work together to give you your final product, if you want to call it that. So let's now talk. We mentioned tuning the alarm system before, so here's some notes on tuning the alarm system. Point 1, analyze the alarm history. You can do that by looking at logs, alarm logs, to identify any patterns. Does it always happen at a particular time of day? Does it happen at day, during the night? Does it happen during adverse weather or wind or whatever? Analyze that, and that will give you an idea of environmental issues or incorrect settings or operator error for that matter. To minimize alarms, adjust schedules. Make sure your schedules are aligned with actual building use. This is for access control, of course. Shunt trusted access. What that means is when a door shunt is basically a feature in access control systems that temporarily disables or bypasses certain functions of a door. So if you want the cleaning crew to come in, say at 7 p.m., you could either put that on a schedule, which is probably not advised, but at least you can hit a button and allow the door to be open for the cleaning crew so they're not constantly alarming the system as they force enter the door or whatever. So those kind of things can be done. Fix any nuisance causes. So that's environmental factors, of course, as we learned. So that would include HVAC, airflow, that can cause problems with certain alarm types indoors, wildlife or vibrations outdoors too. So if you correct these, that improves reliability and keeps operators focused on real events. And that's what we're really trying to do. We're trying to cut down on nuisance alarms and false alarms to make the operator's job easier so they can concentrate on what's really happening. Correct misapplied devices. So sometimes the wrong sensor type or placement causes false alarms. That can be done even if it's a good, well-designed system. Things can happen once you get on site with that sensor. You can discover after the fact that it's maybe not the correct sensor for that purpose. So relocating or replacing the sensor with the appropriate device restores proper system performance in most cases. And use local monitoring. So that would be lights, audible alarms, and those can help staff respond quickly and confirm alarm causes before escalating. So on tuning the alarm system, the final takeaway is the alarm system is only as effective as its tuning. So by eliminating nuisance and line operation with real-world conditions, you build operator confidence and ensure alarms signal true security events. Okay, so let's now move on to testing and warranty. There's always questions on the testing process. They can be, Nelson's prepared quite a few good ones at the end, so hopefully we can get into those quite a bit. But you should test the equipment, the people, and the procedures. And a physical security system is a mix of equipment, people, and procedures. That is a physical protection system, or PPS. So test those all together, independently, but test them all as a working cohesive unit. Use acceptance and reliability testing. So acceptance testing confirms that the system meets the design specifications, while reliability testing validates that it performs 24/7, and consistently over time, basically. Both are essential before handover. And post-implementation tests, so that would be after the system is in use, you would do follow-up testing to verify long-term functionality and uncover any hidden issues. Sometimes it can take weeks or months to iron out a very complex system. So this is typical of having done that, or having to do that after installation. And the final takeaway on this slide is testing is not a single event, but a continuous process that builds confidence in the system's performance and protects against future failures. So let's move on to pre-delivery and factory testing. This is something that a well-run system integrator or installer or contractor should be able to do. They should be able to build a representative system, either in the warehouse or in their shop if they have enough space. But the idea being is to assemble the components that mirrors the final installation, just to test the concept in not the same environment as you're going to go into, but just make sure connectivity is good, that devices talk to each other as needed. And this allows you to build up some knowledge on how the system may work in the field. Testing should follow standardized pre-approved procedures to ensure consistency and provide confidence that the system will operate correctly once installed. Record any data. All your baseline testing must be documented. Anything you see in this representative system should be documented and worked on either in the installer's lab or warehouse or whatever, or when they get on site, take a note to have a look at this on site. Fix deficiencies before shipment. So if you're in that lab environment, if there's anything obvious that means communication between two products are not working, fix that before you ship it and get it on site. That will make things so much easier when you finally get to building the system on site. And the number of times I've seen this not done simply because the contractor just doesn't have the ability to build the system anywhere It's quite a lot. But when you do get a good integrator or contractor who has the space to build, they will do it. Final takeaway on pre-delivery factory testing. Factory testing ensures problems are identified and corrected early, and that will save you time, reduce costs, and provide assurance that the system will perform as expected in the field. Okay, site acceptance testing. Certify readiness. Confirm that the system is fully installed, configured, and ready for use before handoff. Demonstrate all functions. Walk through all system capabilities to ensure they operate as intended. This should be done, of course, for the customer or the client, so they can see it working. Verify performance and error rates, measure the accuracy, speed of alarms, the number of false alarms, nuisance alarms you get against agreed standards. And the customer or client can stop testing on a failure if they want to. They can say, okay, stop there. Let's have a look and let's wait and then move on. But the customer or client has that control, should have that control over the project on acceptance testing. So site acceptance testing protects both the provider and the customer by confirming the system performs as promised before final acceptance. Next up, reliability and availability testing. So you should be doing 24/7 testing. You should simulate real-world continuous operation to confirm the system can handle the long-term stress. Absolutely no unauthorized repairs. Make sure the repairs are approved and they're documented, because you have to document things that go wrong, especially on the initial rollout of the project, because that can help you further down the road. You should be able to do failure analysis and reports, document every issue, determine root causes, and report findings clearly. And repeat until reliable. Testing is basically ongoing until the system consistently meets required reliability standards. And the final takeaway on this slide, reliability testing proves not just that the system works, but that it will keep working under real operating conditions. Post-implementation testing. Operational performance post-maintenance tests. Okay, so here what we're talking about, once the system is live, it needs to be regularly tested to ensure it functions as designed. And it must perform under expected loads and continue to meet security goals after any maintenance. So that's what they mean by post-maintenance tests. Subsystem and limited scope tests. So not every test requires a full system review. You can do periodic checks of subsystems, maybe the camera system, maybe part of the camera system, and also access control too. That can uncover small issues before they affect the entire operation. And it's a good idea to bring in an external party, maybe yearly, maybe a consultant, someone you can hire to have an independent, unbiased assessment of the system and compliance. And this helps identify any overlooked risks and validates your internal testing too. So the final takeaway on this slide is post-implementation testing keeps systems reliable, ensures continued compliance, and provides confidence that security measures remain effective over time. Warranty issues. Typically, a product or a system has a 12-month warranty. Sometimes it's longer. Sometimes the manufacturer will sell you an extended warranty, but typically it's 12 months. Always define response times clearly, so everyone understands how quickly issues must be addressed if something was wrong. There should be a known procedure and an idea of how long and how quickly issues are going to take to get rectified. Keep spare inventory on hand. Keep some cameras around, keep access control readers, anything that you can swap out quickly. It's a great idea to have spare inventory. Make sure you do clear reports and logs for warranty issues so that you can show to the manufacturer. And align warranty with SLAs. SLAs are service level agreements. So a warranty guarantees a product's quality and usually promises repair or replacement in the time frame. An SLA is a contract for a guaranteed level of service performance. Final takeaway, a well-structured warranty reduces downtime, supports accountability, and ensures the system continues to perform as expected after installation. A very important part, and this is something that I can't stress enough, training. Without training, technology can fail. Not the technology itself, but if it's not being operated correctly, it may as well be a failure. Lack of knowledge leads to errors, misuse, and reduced system effectiveness. Training needs to be planned. You should have a schedule for training. And the trainer should be certified on the systems they're training on. So typically the manufacturer will have the ability to do very comprehensive on-site training, or maybe they have their own central location that they fly people into. A lot of them prefer to do on-site because you're actually with your own equipment there. But trainers from most manufacturers are typically certified on the product they are training on. Final takeaway, a security system is only as strong as the people who operate it. Plan certified training ensures technology is used effectively and reliability. And of course, the training should give that trainee that certification as well. There should be, for general training requirements, there should be courses for various user types. There should be operations trainings, administrator trainings, and maintenance training. I went to some trainings from some of the major video management system companies, and they were always very good at asking what you needed. Was it operator training, admin training, or something else? And you could then not get bogged down with the details if you want to do just operational training and you don't need all the admin stuff. So most manufacturers will give you that level of various training. And of course, the admin would need to know how to dig into the system and change maybe permissions for operators. The operator should be very familiar with the overall system, how to get the best out of it. Training should be supported with clear documentation, manuals and materials, usually reference materials, of course. And the content and the schedule should be customer approved. So it needs to meet organizational needs and align with their daily operations. Training topics should be system administration, as I mentioned. Admin should be able to know how to configure users, permissions, and access levels. The system monitoring, the operator, they would need to know how to interpret the dashboard, respond to live events, and recognize irregular patterns in real time. Alarm events require consistent responses. So training ensures that operators follow procedures correctly. If an alarm happens, there should be an event list of what to do if a certain alarm is received. Troubleshooting and maintenance, system downtime can compromise the system. So anyone who wants to get their troubleshoot and maintain on site, if it's an in-house employee, they should be able to do that from the training provided. And sometimes a system overview is beneficial for everyone being trained. So in other words, just a huge map view of how the system works, block diagrams, that's a very good way to help staff get familiar with the system. And that's it for Domain 3, Task 3. Before I move on to Domain 3, Task 5, does anyone have any questions? It's a lot of stuff, I know. If not, I'll move straight ahead to Domain 3, Task 5, monitor and evaluate program throughout the system life cycle. So we're going to start talking initially about maintenance. We're going to talk about planning for local support and spare parts. And the core pillars of maintenance should be, of what we're talking about should be maintenance, evaluation, and replacement. We're going to talk about these various aspects. So for maintenance, there's two types. There's remedial and preventative. Remedial is fixing the problem. Preventative is making sure the problem doesn't happen. A single integrator reduces issues. That is, I found that a well trained, capable integrator who can do access control, video, alarms. It's a very valuable resource to have because it's one-stop shopping for the customer. Maintenance should obviously minimize downtime and keep your documentation current. So if there's any updates to manuals or documentation, keep that current. Final takeaway, strong maintenance ensures reliable protection, fewer failures, less downtime, and systems ready when needed most. Let's talk about remedial maintenance. For remedial maintenance, you should define roles, who is responsible for what, and the SLAs. This should be clear service agreements, or SLAs should be defined at this point, and everyone should know the roles, and the roles should be defined clearly for them. Some critical components need fast response. Access control or surveillance can't be down for long, especially if it's in a critical area. So that requires priority handling. And make sure you map responsibilities across vendors. If you're using multiple vendors, make sure you know their responsibilities. And that's important to avoid finger pointing, which happens, and any delays associated with that. And yes, pricing reflects complexity. More complex environments or stricter SLAs will naturally increase service costs. Final takeaway, effective remedial maintenance minimizes downtime by setting clear responsibilities, prioritizing critical systems, and aligning service costs with operational needs. Preventative maintenance. You should come up with a checklist. It should be a scheduled checklist. That includes inspection, cleaning, testing, anything with a lens or an aperture or something that points to another sensor. That should be looked at, inspected, and cleaned if necessary. I would say it could be a monthly basis, typically every quarter, at least it should be done. Functional testing, run tests to confirm all systems work as intended. Adjust devices as needed. As devices settle in, they may need more calibration and fine tuning. And test any backup power you have, like UPSs or generators or batteries, and make sure they do work. Make sure that they do what they're supposed to do so that you're not throwing a curveball during a power cut. Final takeaway, preventative maintenance keeps systems reliable, extends equipment life, and reduces costly emergency repairs. On evaluation, this is knowing when replacement is your option, or knowing the difference about when to replace versus when to repair. So is it more cost effective to replace or repair? You must decide that. Consider costs, consider spare parts if there are any for that product, and obsolescence. Maybe the product is going away. Maybe it's an older product that they don't make anymore, so you need to replace it. Engage stakeholders at this point, security, IT, operations. Make sure that the decisions balance functionality and the budget. And align any software upgrades or new software with IT standards. Very important. Final takeaway, regular evaluation prevents wasted resources and ensures the system evolves with organizational and technological needs. For replacement, this may sound a little crazy. I don't know many people who do this, but it's really good advice. You can budget in cyclical replacement. In other words, as systems age, plan financially for predictable replacement cycles. Every 5 years, perhaps, maybe you need to upgrade your access control readers. They get use with, especially if they have keypads on them, or less if it's something that's used a lot. There's shifts going on. There's technology shifts, as we discussed last week. Analog is going to digital for most systems, and proprietary systems are going to open systems. So that should sway your thoughts on whether to replace or repair. So this kind of swings in the favor of replacement. Biometrics, credentialing is growing, so a fingerprint and a card swipe for certain areas. That is something that can be done with modern access control systems. And PSIMs, physical security information management systems, they approve awareness. That's everything on one dashboard right in front of you, so you can see all of your inputs on one screen. The takeaway is replacement isn't just about swapping old hardware, it's about staying ahead of threats, aligning with new technologies, and maintaining a future-ready security posture. And that's it. That was a fairly short one. That's it for domain 3, task 5. I apologize if I went a little fast. I was trying to get in as many questions for the quiz that we have. So on those 2 modules that I presented, does anyone have anything they're unsure of, or any questions on what I said? Any clarification needed? Or any arguments with what I said? I'm fine with that too. Okay. If everyone's good, we'll go on to the practice test. Nelson, did we want to do 1 hour only tonight, or do you want to go longer? I can't remember what you said. I apologize.
Well, we can try to do, we have 15 minutes. I think that it's not too much questions. I have basically a quick poll after we end this section. It will
Okay.
be 7 questions, but it's a poll to get some feedback from the
Yeah.
attendees. Okay.
Okay.
But it's,
Yeah.
yeah, we can do 1 hour. And I think that we can finish it's not too many questions with this. Let's go ahead.
Okay. All right. So these are nice to set up the questions. Some of them are from what we just spoke about, domain 3, task 3 and 5, but there's also questions sprinkled in there from previous sessions. So let's start right away. So this is from today's session. During the site preparation phase of a PPS, what is the contractor's most critical initial action regarding the proposed equipment locations? And I'll try and give you a set time. I'll start my stopwatch for 20 seconds, but feel free to either answer in the chat or whatever means you want to do. Okay. And the answer, of course, is, I apologize for those that display up there, verifying that physical site conditions align with the design package and reporting any necessary changes in writing. Very important. Any changes have to be documented. And that's the POA snippet down there. What is the primary reason for emphasizing maintenance planning as an essential component of security system design, even before installation? There's various thoughts about practice tests. I actually like them. When I was studying for the PSP and the CPP, I had friends read me the questions on a daily basis, and I would do my best to answer them. If I didn't know the answer, I would research it. That's the thing that you got to be able to do, is if you don't know the answer, don't worry, research it, find out where you're wrong, and then go on. So I know we're not going to get these exact questions in the test, but they're a good cross-section of what you could get. And the answer is to guarantee the security system successfully fulfills its mission and to minimize the impact of inevitable failures. A security contractor finds that essential precursor work by other trades, this was one of the first slides we did, has not been completed, delaying their ability to install the security system on schedule. What is the immediate and most appropriate action for the security contractor? Okay, so the answer there is, of course, immediately notify the owner's representative to arrange for precursor work completion, and if necessary, seek a schedule extension or waiver of penalties. The contractor must speak up at this point because he's protecting himself. Oops. Which of the following best distinguishes remedial maintenance from preventative maintenance in a security system program? This is a good question. You may see something similar to this. Okay. Remedial maintenance corrects faults to restore system operation. That's exactly right. And there's the POA snippet down there. When installing electric door strikes or bolts, what crucial design consideration dictates whether they should be configured as fail-safe or fail-secure? This is from a few weeks back. And it is good to mix up the questions like this too, not take them all from the same domain and task at the same time. Because that's what the test is going to be. So the answer here is, of course, the specific application determines if the door should be released or remain secured in case of a power failure. In the context of complex and integrated security systems, what is identified as a primary advantage of selecting a single contractor or integrator to manage all maintenance requirements? And of course, the answer is, as we mentioned, establishes a single point of contact for problem diagnosis and management, reduces finger pointing. Not my problem, it's his. Stops that. When determining the ideal location for control panels, which combination of factors best ensures maximum security and operational efficiency? So the answer to that is C. It should be internal in a secure location. Look, position out of easy reach. You don't want people messing around with your access control panel. When negotiating service levels for a security system maintenance agreement, what factor is most likely to cause a rapid escalation in costs for guaranteed response times? And this is the POA speaking, by the way. As always, these questions, this is what ASIS thinks. The cost for guaranteed response times of less than 4 hours can escalate rapidly due to the staff, hours, travel, and equipment required. Question 9. Why securing and controlling the documentation related to security systems, such as contract schematics and wiring pathways, considered crucial? And of course, to prevent unauthorized dissemination of security system countermeasures, which could compromise the system's effectiveness. For digital video systems utilizing a TCP/IP backbone, what is the maximum permissible run length for any single connection to ensure optimal signal integrity? And of course, I hope everyone knew this. We spoke about it quite a bit. It's 100 meters or 328 feet. And as we mentioned, there are systems that can extend this, various methods of doing it, but the standard, the IEEE standard, is 100 meters for category cabling. As a general rule of thumb for budgeting, what percentage of the capital cost of equipment for a location should be allocated annually for spare parts purchases? And the suggested number is 5%. As per the POA Chapter 16, Section 16.11, page 569. For video recording and switching equipment, what is the strategic purpose of programming video screen layout such that geographically related video cameras are displayed on one screen and configuring GUI icons on maps?
Yep.
I think this is fairly evident. Of course, it makes it easily readable. It enables the console officer to quickly assess alarms. Regarding backup power for security subsystems, what critical aspect of switchover functionality is necessary for effective operation of all devices, and how is it typically achieved? And of course, switchover must be immediate and automatic, requiring batteries to provide instantaneous power before a generator obtains full power. What is the general requirements for installing interior wiring, including low voltage wiring outside the security center, control monitoring console, racks, and cabinets? Okay, so the answer should be easy. It's installed a rigid galvanized steel conduit conforming to applicable standards. Beyond the normal amortization of equipment, what are the key justifications for considering the replacement of an existing security system? This is something we discussed today. If it was me getting something for myself, I'd choose B. I just want to have the newest technology. But the real answer is, of course, high maintenance costs, lack of spare parts, obsolescence, etc. We did discuss this. It is maybe time for what, one or two more questions?
Yep. One question.
Okay. Before applying power to a physical protection system during system startup, which of the following is a mandatory prerequisite from the provided list? And the answer is all security system items have been set up according to manufacturer's instructions and system wiring has been tested and verified. It is 7:30. Nelson, I don't know if you want to go on a couple more questions or stop there.
I think that we can, all the questions you can find not today, but next week, all those questions in the website. I will upload in the website because I didn't make that. The domain 1 question is not there. I will upload all of them in the website for next week and this domain. But let's, I have basically, I want, you see, we have a question. Yep, Tom. Do you have a question, comment?
I have a comment. I want to thank you guys for a really excellent study group. I didn't want to just put it in a chat. I want you to hear it from me. I've really appreciated it. I've had some challenges at times getting to the session, but I'm really glad for the instruction, the interaction, and the education. So I just want to thank you guys.
Well, thank you very much.
Thank you. I would put in the chat. Let me see if that works. It's my first time doing this. We have a pool. You should see that in your chat. Can you see the pool?
Yes.
Okay. If you don't mind, or answer those pool. It's basically a feedback for us, to see, to find. I think that always we can improve. Any feedback will be good. When you go in the pool, you can see the 7 questions or only 1 question.
I don't understand the second question. It just says question and it identifies 3 domains.
Oh, okay. Basically, the second question is which one of the domain, it's a mistake, but which one of the domain do you like the most?
Okay. Got
domain 1, that was security principles. Domain 2, that was security system design. And domain 3, that is implementation of physical security measure.
Okay.
Yeah, for some reason, Nelson, I'm getting an error message that says this feature isn't available yet in your version of Teams. There we go. Finally got it. No, I didn't get it. Yeah, I don't know. Maybe I need to update my Teams, I guess. I don't know. That's strange.
I had the same error message, actually.
Well, yeah, maybe that is one of the things. We have a lot of, not a lot of, but yes, some restriction in our IT department. Take serious cybersecurity. In some cases, though, using those tools for people that is not in the company network, it gives some issues. It could be.
If you want, you can just shoot it to me in an email, and I'll respond right away.
Okay, I will send those questions to I will send the question in the email, like I do every week. I need to pause the video for this week, and I will share those questions with you guys. And the rest of the team, the rest of the study group, some of them couldn't attend at this time, but they go to the website and watch the video. Well, say that. Thank you for you attending, to be here. Thank you for share this acknowledgement with us. It has been a pleasure for me to do this. We don't see next week, but if you have any question, send me an email. Also, I would like to keep posted when you pass the test. Shoot me an email. I would love to know that you passed the test. Thank
Yes,
you.
me too, definitely. And
I
I'll
can't
also
wait to
put
brag
my,
about it and tell
yeah,
them how
there you-
great you guys are. 'Cause I've really appreciated this session. I mean, I'm just stoked about it. I looked for a study group for a while, and it just did not appear. And I'm glad I grabbed the first one that came along. You guys are great. You know, I'm very happy. Look forward to bragging about how you've been a help to me and the practicality of the PSP. And that's what I love. So I don't want to go on, but I'm on a fanboy moment, and it's like I'm really grateful for the class, and I really appreciate it.
Yeah,
Thank you.
absolutely.
thank you.
Thank
Absolutely.
you.
Well said. Well said.
And also I'll put my email address there if you need me for anything, or you can go through Nelson and he can let me know too.
Yep.
Yeah, appreciate you both. Appreciate you both.
Okay.
Great,
Well,
thank you.
see you. Bye.
Take care, bye.